I think it's really good evidence. The moon. It doesn't. Do you guys agree that it doesn't change in angular size like substantially throughout the day or throughout the night whenever it's out?
It does change about 14% from a mini moon to a supermoon, which would probably to me indicate that the supermoon is the correct moon and the other bit is it's just shrunk because of lensing and whatever.
Yeah, but in a single day, it's not going to shift 14%, right? It's not even going to shift 5%.
Yeah, but the question is, yeah, I would agree with that. But okay, maybe on the days where there is a supermoon, it still restores back to its original size anyway. So on those type of days when you see the bigger thing on the horizon, it returns back to a more familiar size as soon as it leaves the horizon type of area. You know what I mean? So I guess there are days where you can get size changes.
Yeah, like horizontal is that's fairly well understood. But like, no, I'm saying
Explain.
vertical. Vertical, it changes a good bit on the horizon, right? Like that's
Yeah,
measurable. That's easily seen. But horizontally, it doesn't change very much on a day to day, on in a single day, right?
yeah, but that's what I'm saying is you can take a particular day and you can see a change throughout the whole thing. But if you compare horizon to horizon to horizon and zenith to zenith to zenith, that's one thing. But actually seeing a change over a whole day, yeah,
Sure. Sorry, maybe I'm not saying it correctly. I meant like there's not a 100% difference in size, but from when it rises to middle to when it's leaving your view, right?
generally yes, I agree with you. Generally yes, and I think that's probably the case because it's a certain distance or a certain thing is happening when you don't see the changes. But other times you do see the big changes, and then you start to see comparables. But yes, I do agree with you.
Okay. Because like I'm struggling to think of anything that can get closer to you, like substantially closer to you, but it doesn't change notably in angular size. Do you have an idea of what's going on there?
Yeah, I was thinking like temperature type of thing. Maybe when something is just conveniently staying the same amount of size, but it's changing shape. I think you might be going on about the general thing of the sun and the moon and the sky generally staying the same. And then people would just say that's just down to magnification of the atmosphere and stuff, I guess.
Like you're saying, it's more magnified on the horizon, so it's bigger than when it's directly overhead, which is smaller in apparent size. Because like it would literally, if it's a physical thing, I know most people on your side don't really hold that position. It seems like most people think it's a projection or you have no idea what it is. But
I think it's
that
interesting.
it's got to be.
Sorry.
Go ahead.
Yeah,
No, no,
I heard the other day that this guy called Eric Dollard said that apparently you can't see the sun or the stars when you're in space. And it got me thinking maybe one thing is real and the other thing is just a result of.
I think it's an exposure thing, is what you're talking about. Because like you can be in a city at night and you can't see the stars at all, and it's just because there's too much light around you. So if you're like on the dark side of the moon, you would be able to see stars. Just nobody's done that yet. Well, there's robots that have and satellites.
Yeah, I guess I was just thinking when the person made the statement, it was more the case of generally. It was a more of a general statement that you don't know, you can't see the sun or the stars when you're in space. Um, but yeah,
The
like you
sun.
said, it could have. Yeah, apparently you can't. This guy reckoned you can't see the sun or the stars in space.
I've never heard that. Like other than when you're blocked by like a large object, you're just saying at any time satellites can't see the sun, or somebody said
Uh,
that to you.
no. This guy Eric Dollard, a lot of
Yeah,
people do recognize him here, and he was the one that said that. So how he interpreted that, or how it's interpreted, I couldn't confirm, but he just seemed to say that maybe a person can't see it in space. But yeah, that's a lot of that's a lot of big words to say, isn't it? I mean, to me.
I've just never seen something where it gets so much closer to you, and it's so consistent in size, and you can move left, right, north, south, east, west, and it's going to be the same angular size. It seems like it's an object that's a very far distance away, and I think it's rotating around us because you can even shoot radio waves at it and bounce radio waves off of it and get the distance or get the time that it takes for the light to bounce and come back, right? and that does the same thing. It says this like it's approximately the same amount of time.
Yeah. I hear you.
So it's 250,000 miles away,
That's my understanding.
and one of those craters there, the largest one, is 60 miles across. Apparently, the one that's
Uh,
clearly visible.
I'm not a moon cartographer. I have no idea. That sounds about right.
I believe that's the one. So
Yeah.
we're supposed to believe that an object 250,000 miles away, we can zoom in with a camera and see it.
I don't see why not. Do you think the photons wouldn't be able to go that far?
So you think that sounds reasonable, that you can zoom into an object 250,000 miles away with a camera?
I mean, a camera zooms in on anything that you point it at, especially if it's big enough, right? Like, I don't see why the light wouldn't. Are you saying the light wouldn't be able to get to you, or just be too small to see?
No, I didn't say anything. I just asked. Do you think that it's possible to see an object 250,000 miles away? And you said yes. Okay,
Yeah,
that
I don't
answers
see why
my
it's
question.
logically. Okay. Do you see a logical problem with it?
I might, yeah, like 250,000 miles away, and I can zoom in on it
Yeah, why wouldn't you be able to?
because it's far.
Yeah, but like hypothetically, if something was big enough, you would be able to see it from a super far distance away, right? Like, there's
Yeah,
nothing.
but we're not talking
Photons
about the
won't get
moon
tired.
itself. We're talking about a smaller object, right? I picked a crater, 60 miles.
It's pretty big.
It's pretty big, huh?
I mean,
Okay, all right.
and if you look at it, it's pretty dang. It looks pretty dang small up in the sky.
But so you believe there's an object in the sky
Mhm.
that's a quarter the size of what they say we're on, and it's falling around us in a circle.
That's a decent enough way of explaining. Sure.
Okay, all right, fair enough.
Do you have a more parsimonious idea? Yeah. What do you think it is?
I have no idea, but
Well, I would
to
have
go
added
to
one
that
extra
right
word.
away, to go to that assumption right away, and then
Mhm.
question why somebody would not believe it, I find that kind of presumptuous, like kind of weird.
I would
Well,
have
I
added
didn't
one
go to
extra
it.
word when you were describing it. I would have said falling up.
Yeah, it's falling up too. Yeah, that too.
Sure. Yeah, it's getting like a centimeter away, further away every year or something like that. But
Yeah, that's up.
I mean, I
Falling up.
sure, yeah, it's rotating away from us. It's slightly faster than it's being pulled in. But like I wouldn't say that I can't. I didn't come to this conclusion first off. Like you do some investigating, you look at the predictions that are made regarding it. It seems pretty plausible that scientists very well understand what this object is, right? Like, why would radio waves be able to bounce off of it and the light comes back in the predicted amount of time?
So you bounce a radio wave on this
Mhm.
thing, it comes back, right? Gives you a
Yes.
number,
Yeah.
and that tells you that it's a giant rock going around, falling around and away from you in a vacuum of space.
Well, it
That
tells you
rate
that
of
it's a
bounce
certain.
equals that.
No, you shoot a light wave, radio wave at it. It takes a certain amount of time to come back. That can give you an idea of the time if you know how quickly the light wave can move. Like, you don't have to. You can add those extra things onto it, but I mean, no other information. Just that a light wave moves at a set. If you know that a light wave moves at a set velocity, which I don't know why you wouldn't be able to do that,
No,
then I
but
think it's a
perhaps you
pretty
didn't hear my
reasonable assumption.
question. Let's say, assuming I give you that that's the distance, right?
Sure.
I give you bounce the radio thing, which is like, I mean, it's hardly like a proven thing, but let's say it is. I'll give it to you. You bounce a radio signal there, it comes back, it gives you a number. How does
Mhm.
that equal? That's an object falling around and away in space. How does that simple measurement, let's call it, which it's not,
Sure.
how does that equal the rest of all the other stuff?
So if you are granting for the sake of argument that that is an appropriate measuring way of measuring things, then it would show you that it is a constant distance or fairly constant distance away from you, no matter where you are on the surface of the Earth. If that's the case, then it would have to be a ball because there's no other object that you could be on. I mean, I guess you could be on like a cube or something, but it could not be close and local because the
What if it's a
distance would
plate?
vary greatly.
What if it's the shape of a
Well,
plate
then it would
and it
change.
looks like a ball?
Yeah, but if it was in the shape of a plate when it's directly above you, it would look like a circle. But as soon as it moved away from directly above you, like as soon if it got really close to the horizon, it would look like a little sliver. Because you move a circle up or down your field of view, it looks more oval shaped, elliptical, I think is the correct word for it.
Well, to me, that sounds like an assumption
You can do this with
because I'm
plate,
sure,
like
I'm sure you must have seen that meme where it shows all those different shapes, and then the guy turns it around. Well, it's not a meme; it's like a whatever short video,
demonstration.
and they all look, yeah, they all look like one is a bowl and it looks like a sphere, the other one is a plate and it looks like flat. You've seen that, right?
Is that something that David Weiss does? I feel like I've seen David Weiss do that once.
Everybody I probably here has posted that meme or thing, probably. I wouldn't
Yeah, but
attribute
like, I
it to
mean,
him. Yeah,
sure. But I mean, just imagine you have a plate, just a small dinner plate in your hand, and it's, vertically oriented. So you're looking directly at it and you're seeing a circle. As soon as you start to rotate that thing away from horizontal or from like towards horizontal, away from vertical, it does not look the same anymore. And you could do the same thing with if you ran that thing to the left of where you're standing and you're out in the field, you run it all the way off to the left and you keep facing straight, it would start to look the same way. It would start to look more elliptical. If it's a bowl shaped, I guess if you never saw the backside of it, then it could potentially be a bowl shaped object. But I think that's not as parsimonious an explanation, just because we do see other spherical objects that clearly do rotate and we do see the backs of them.
yeah, but you can't. You get my point, right? You can't be certain. Is what I'm saying.
I mean,
You have to
we could
believe
go
this.
there.
Somebody told you. I'm sure you're a NASA believer. You believe in the Apollo and all that, right? But there it is. Northern Rebellion just put it there.
I
Like
mean,
on
but
your
like,
own,
what?
there's no way. You think you would have came up with that? What they say the moon is on your own?
I never would have discovered Australia on my own. I don't think that's a very good. I think that's a pretty bad argument, to be honest. I would never be talking to you on this phone if I was alone.
Yeah, but do you
We got to
think you
rely
would
on
have
each
ever
other.
looked at the moon and said, "Hey, that thing there, that amazing thing there, that glows, right? A glow, it's falling
Yeah.
around me all the time." Would you ever like come up with that notion, or would you think it's magically floating up, or some other? Would you ever entertain the idea that that's a constantly falling object around you?
I don't think. No, I don't think so. In all honesty, but again, I think that's a pretty bad argument because we got to take information. I wouldn't be speaking English if I was by myself. We got to rely on the other people for information, and there are things that we can verify.
Yeah, that's what I was going to say. You can verify the English language, right? Like we
Yeah,
understand each other. Maybe it's crazy they spell cat with a C, but don't get me started on that. But we can verify all that, right? But the moon, how are you going to
yeah.
verify?
You could shoot a laser at it and see a well, not a laser. It would be expensive, but you could shoot a ham radio wave at it. If it bounces off the moon and you receive the signal back, that's a pretty good indicator that it's taking that amount of time for the light to go from you off that physical object in the sky and get back to you. If that comes back at a fairly consistent time, then it's got to be a fairly consistent distance away, right? Like, do you have a problem with? Do you see an issue with the methodology there?
No, didn't I give that to you for argument's sake, so we don't argue about that? Didn't I say, okay,
Yeah,
I'll
yeah,
give you the distance? Yeah. But how does that
yeah.
extrapolate to the rest of the stuff? A falling object, and like Jeremy says, not only falling around you, but away from you at the same time. How does that
Sure.
extrapolate to that?
Well, let's just say we can't prove any of that other stuff. We don't have sophisticated equipment or knowledge to be able to verify the other things. What can we conclude from just that? What I'm saying is that it's a consistent distance away from us. And if it's doing like, I don't know if you have a particular map like the Gleason's or AE map, it cannot be close and local because it would get the delta in difference from directly above you to when it's leaving your site would be such a big difference in duration for that light to go there and back. It would be a much bigger distance. Do you disagree with that?
I'm not sure I quite understood that. Again, a distance thing?
Yeah. So,
Are
like, you
saying
understand what
shape
I'm saying?
because of?
Sorry, go ahead.
No, I don't think I understood that last part.
Sure. So you understand what I mean when I'm saying that it's a consistent distance for the globe idea, right? Because it's so far away, the amount of distance from any position on Earth is almost exactly the same, plus or minus less than 1%, right? That makes sense?
Okay, so back to the distance, right? What
Yeah.
about it?
But if you had a flat map and the sun and the moon, let's just say the moon, just the moon. The moon is local and it's only so far away that if you shot, let's say it's right at the horizon and you're on the equator, and the moon is also, the GP of the moon is directly on the equator, you're shooting that distance, you're shooting that light, it bounces off the moon and comes back, you get one result. It's one distance, let's say 1 astronomical unit. It's directly above you. at local solar midnight or whatever, it's the same exact distance. Maybe that could be on a concave Earth. That's possible, but it cannot be if it's actually getting outside of your field of view. If it's directly above you, it has to be a lot closer if it's a local object.
Have you ever seen the moon direct? The moon. Have you ever seen the moon directly above you?
Like I've never gotten a theodolite out and measured it directly above me. Is that what you're asking?
Yeah, I don't think the moon has ever been directly, like above me, directly straight up. I don't ever recall that happening.
Sure, but the concept works either way, even if it's not directly above you. Just measure it when it's closest to directly above you, and then furthest away from directly above you, right? Right on the horizon. Or maybe just a little bit above
you're
the
going
horizon.
to the shape that the shape doesn't appear to change. Is that where you're going?
The distance from your position to the moon is almost always the same distance, and that can't be the case on a flat Earth. I don't see how it can be.
Oh, you mean
And that
the
matches.
face? Oh, I see what you're saying. Okay.
And
Why?
that matches
Isn't it supposed to
the
be rotating? Isn't it supposed to be rotating?
why on the flat Earth.
No, I'm not saying shape or anything. I'm saying isn't the moon, the story of the moon, supposed to be rotating at the
Yeah, it
same time?
rotates around the Earth.
Yeah, that's why
Well, I
you
mean,
only
it's
see one
tidally
side,
locked.
right?
Well, the reason you only see one side is because it's tidally locked. But you get
Tidally
what I'm
locked.
saying about like,
That's an impressive
yeah,
term right there.
uh, sure. But you get what I'm saying about the flat Earth, right? Where like, how do you, if you grant the premise of it, and I'm not saying that you do, like, you don't have to say that this experiment is valid. Although I'd like to hear if you think it's invalid. I'd like to understand how that's possible on a flat Earth that the moon is approximately the same distance away from you.
I'm not sure I understand the question, and I don't argue
here's
for
the problem.
flat Earth, so yeah.
Here's the problem though with the thing you're saying is that okay, now we're doing geometry on the sky, and if you start doing that, you're going to debunk the globe radius fairly quickly. Like you want to shoot something at the horizon at the moon and say that's where it is. It's going to be a problem.
I'm sorry, could you say that again? What's the problem?
If you want to shoot something at the moon and then say okay, that's
Yeah.
where the moon is. These are the dimensions of it. Yeah, you're going to debunk the globe radius fairly quickly. Now it's fine if you just care about winning a debate with a couple dudes on the internet, but you'd be debunking the whole mainstream model.
Why? I don't see how that follows.
Can I make the argument?
Well,
Glober to Glober?
shoot your radar at the moon. Shoot your ham thing at the moon when it's stellium eclipse is happening.
Would it matter if an eclipse is happening? How would that debunk
Hey,
the radius value? I'm confused.
Can I try to argue Jeremy's point?
Well,
whatever you
solid eclipse would mean that both the sun and the moon are above you, like above the horizon, when the eclipse is taking place, which geometrically would be impossible unless there's some sort of refraction taking place. So what he's saying is shoot your little laser or whatever you're saying you can bounce off of these objects at those things. And if you can do that, then it completely debunks the radius because it's an object that's at an apparent location, not an actual location. So all you're discussing or have been discussing with SE is the assumption that the object is in its actual location when it's always in an apparent location.
That's another great point. Yeah.
Sure, and like a stellium eclipse, right? You're talking about these things are right on the horizon, and I don't think that anybody disagrees that refraction is a thing, right?
They're not right on the horizon.
That's
How far are
Jeremy's
they
point.
typically above the horizon?
Depends
That's
on the
Jeremy's point.
specific-
If you say that refraction is a thing, it means that where you see the moon is not exactly where the moon is. So
Yeah, but
yeah, you can't take
Sorry,
that
go ahead.
assumption. I'm just saying that's the point. If you can't ignore refraction, otherwise the predictions from the globe wouldn't exactly match what we observe. That essentially is Jeremy's point.
sure, and I think that's a fairly valid criticism. I think the way that you could get around that, though, and I think we can all agree on this, that refraction is highest right at the horizon line, right? So, like, I don't know of any hugely distorting effects when you're 15 degrees above, horizon. If you start with your measurements only 15 degrees above horizon, it would still demonstrate the same point. You don't have to be right on the horizon.
All right, but if that's where you're shooting your laser at or your ham radio thing and saying, okay, we're getting a distance now.
Yep.
You're going to say that's not taking a straight path. So the distance you came
Almost.
back with is obviously not correct.
Have you seen substantial refraction for something that's 15 degrees above the horizon?
Yeah, but you don't know where its actual position is now, though. We've come to that conclusion. You don't know where the actual position is because refraction's happening.
Yeah.
So now you're
Are
left
you saying?
stuck in a place where how much is it happening and how much of that light bend to come back, because the more it had to bend to come back, the bigger of a distance it's going to give you.
But I want to make sure I understand your position. Are you saying that we don't understand refraction, and because refraction is happening, we can't make conclusive measurements from things through the atmosphere?
I mean, you can say you understand it, but there could be something else happening, like the second law of thermodynamics and gravity. Both of those in conjunction make gas do things that the other one says it wouldn't do. So going off of that, you got Fermat's principle for the light. Maybe that's what's happening. Maybe that's not what's happening. I don't know. You've never measured the actual position. And, you'd have to have an actual position. Like, okay, the moon is actually here. We're going to shoot the radar here. And therefore, the number we get back is going to be correct. The more it's out of position, the more it has to bend, the longer it's going to take, the farther away it's going to think the moon is.
I mean, I think we understand refraction pretty dang well. We have glasses and cameras and all sorts of things that do a great job of measuring refraction. I kind of get what you're saying. It could be that something's happening to the light when you emit your radar wave or laser, or whatever. But I think the issue with saying that is, if it is something that we don't know of that's influencing the results in this fairly dramatic way, then it wouldn't be consistent, or else it'd be like some kind of super bizarre coincidence all the time. Like the consistent results would bear out whether something like what you're talking about is happening.
You guys always say we understand refraction. We understand refraction. I get it. On small local scales, you want to spear a fish in a lake, or you want to figure out how eyeglasses work. Sure, we understand refraction. Now, if you want to say from here to the moon, I would say, no, you don't understand refraction. You could claim you understand it and claim where the actual position is, but you've never actually checked, measured, made sure. You know what I'm saying?
That's the funny thing, Jeremy. They always understand refraction when they give you the example of light actually interacting with two different mediums. And then they want to say, well, we perfectly understand refraction when they're talking about the atmosphere. And they want to use something like Snell's law when it's actually Fermat's principle, if that's even coming into play, right? And even the subject matter experts basically are just guessing based on the assumption of a known globe radius of objects in the distance on how they appear due to refraction. So it's not like they're actually testing the refraction. They're saying this is what we would expect to see with the Earth being X, Y, and Z, radius value, all of that fun stuff. So we would expect this much drop over distance. So therefore, it's the refraction is this. This is what standard refraction is. So it's just basically begging the question. That's why sinking refraction and standard atmospheric refraction look so similar, almost unnoticeable to the human eye.
I think this is called tropospheric delay, right? When they take the perfect account for the timing correction of the refraction cost.
Well, I say, if you think we don't understand refraction well, I get that you might have that mistrust of our understanding, but I don't think it's reasonable to say we don't actually understand it unless you have a better way of explaining it.
Who's we? And if you're saying that we understand it and the things that we know, can you point me to all the data and the actual experimentation that was done to prove this? I don't want calculations
our understanding of refraction
based on assumptions.
Your calculations could be wrong, though. That's what I'm saying. You've never measured it to make sure your calculations are correct when we're talking about from here to the moon. You know what I'm saying? I understand you have a calculation, but now you have to say, does it match? Is there another effect that's happening? This is the reason why you guys say we can't prove things doing science, is because there could always be some very unknown variable from us to the moon.
No. Refraction is very carefully calculated, though. We know all the angles in a weird, like a straw in a glass, and we calculate it through prisms, the exact rainbow pattern that's going to emerge.
No, that's a glass.
Those are different mediums.
You guys are thinking it's
Yeah,
happening freaking through air and air. That's freaking not a thing.
Yeah, but you were talking about refraction and
It is a
defined
thing.
and being logically calculated, right? So you would just have to extend it to lighter, less dense medium, and you would see how well you can do there. And we have done those experiments.
Okay, so then you
if you
understand
don't mind.
refraction pretty well, apparently. So what is taking place? How do you explain refraction through the same medium? What law are you using?
You know the base density at sea level. Go on.
Sorry, I think this is just kind of distraction from the point, though. If the moon's fairly directly above you, and the light wave is taking just as much time to reach that object and bounce back down to you, it'd have to be going through more stuff, a thicker medium, to slow it down more, to take the same amount of time to reflect back down to you. Conversely, when it's right at your horizon or 15 degrees above, you go on top of a mountain, so you get a little bit more away from the atmospheric effects. It has a perceivably long, it seems like a longer distance, it's out that way, but it's coming back and out in the same amount of time.
Which could certainly be happening, right? Because between us and the moon, there could be, I don't know, superfluid. And a superfluid is more dense than air. So if we have a superfluid that's above us between us and the moon, then you could certainly have light, the propagation of the energy of light taking longer to go through that medium and come back and bounce back, right?
No, because it would
But it's
take way
directly
longer.
Sorry, I apologize, man. It's directly above you. But it's taking the same amount of time, so it'd have to be a thicker media above you when you shoot it directly up. Yeah, but that superfluid would also be present, and probably more of it because you're shooting it at an angle when it's off closer to the horizon,
Sure.
because it's not going on a straight line directly up.
Superfluid. You have a superfluid somewhere between you and the moon, right? And your claim is, I don't know, has anybody done some sort of moon bounce with a laser when it's close to the horizon?
Thousands, yes.
And you get the exact same distance?
No, not the exact. It's a margin of error, and the moon is closer and further.
Okay, so why is it relevant above you or towards the horizon? What's the
Because on a
relevance?
flat Earth, it would be a lot
and
closer
also-
to you. It'd be a ton closer to you.
Yeah, also, I prefer a citation for the laser moon bounce somewhere between
Mhm.
like 10 degrees or less on the horizon. Do you have a citation for that?
Sorry, I can't. I'm driving. I apologize. But I can promise you, if you Google Scholar, Earth, Moon, Earth, radar bounce, or laser bounce, you will get a ton of results. There's a ton of these
Yeah, yeah.
measurements. You can even
But,
do
but
them
we're
yourself.
asking for specifics, right? If you want to claim specifics, that it takes place all the time at,
Mhm.
10 degrees or less, and we have thousands of times that it's taken place, don't say, well, you can just Google moon bounce of a laser and you'll find it thousands of times. Okay, does it fit within the parameters that we're talking about? Yes or no? Have you actually seen that?
Yes,
Okay,
I've done
cool.
this myself. It's pretty good. It's pretty
You've
cool.
done a laser bounce off of
No,
the moon
radio.
less than 10
Radio.
degrees off of the horizon.
No, it was more. It was
Radio?
15, and then directly above. Yeah, radio. Ham
Less
radio.
than 10 degrees above the horizon.
You're bouncing
No, I
ham
said
radios
15.
off the moon. Did you just say that?
Dude, he doesn't know what
Yeah,
he's talking about.
anybody can do it.
Holy shit, dude! You're bouncing
Are you saying it
ham
can't be done?
radios off. Yeah, I'm saying it can't be done. That's silly.
Why?
Because
Well,
they hit the
I know and I
ionosphere,
haven't tested
allegedly.
it, but I don't think Yeah, that's what they say, but I just don't think you can bounce anything off a reflection. I don't think the moon's a rock. I can't prove it though. So, but
I agree
think
with you. You can't
bouncing shit
bounce
off
things
it.
off reflections.
I don't think you can bounce anything off the moon. The
Well,
moon's
he
not a freaking
first he said
floating rock
laser,
in the
now he's
sky.
saying radio waves. I think he's just gish galloping all over the place because he doesn't actually have any of this evidence. He's just making claims willy nilly.
No, I'm driving. I apologize. I would provide you the information if I could, but I mean, I've been on the same point. There's one thing I think is really good evidence, and I think it matches really well with what I was talking about earlier, where the approximate angular size of the moon does not change throughout the night. Where if it was getting drastically further and closer to you throughout the night, it would change in angular size. And I can't think of any examples, large scale or small, that I've ever seen where something gets notably closer to me and it does not increase in angular size.
Dude, the freaking sun does it in a zillion videos. And what the hell do you think a supermoon is? You think a supermoon isn't bigger, or at least looks bigger?
Yeah, there are things like lens. It doesn't increase substantially. It should be getting 100 times bigger. I would think it would get it. If you have another more plausible explanation, I'm more than willing to hear it. I've just
If
never
you
heard
do the
one.
distance
again,
to it,
this is-
nobody's gonna freaking claim the distance to something we can't get the distance to because we don't freaking just make up freaking new magical
Right. Again,
bullshit stories.
this is based off of his assumption that that is a solid object at a specified distance that is traveling somewhere that makes it further away. Right. If it's some sort of light source or a point source of light or anything like that, it doesn't matter. It does not change that much, especially if it's just a perspective effect that's taking place based on the observer, and that seems to be the case. So, plus, simply you can refer to the fact that if it is going into a denser medium, right, the closer it gets towards the horizon, you're seeing through a thicker part of the atmosphere, that you can certainly have something called atmospheric lensing, which is taking place, which makes the object appear as though it's slightly larger than it is anyway. So as it's going further away, it's actually doing the opposite of what you would think it's doing. It's actually appearing as though it's larger than it actually is based on its distance, but it could appear as though it's the same size as it is when it's directly above you, where it's going through less atmosphere. So atmospheric lensing can certainly explain that.
Sure. I appreciate the chat. I'm going to lose signal in a little bit, so I apologize if I cut out here. But I mean, like, I get what you're saying, but I think I would, in order for me to take your position, I would need some kind of evidence that what you're describing is possible, right? Because I've never seen anything where consistently, no matter where you're standing on the Earth, it's approximately the same angular size, where it's super closer and further, yet
Super
same
closer and
angular
further
size.
based on
Do you
what
have something like that?
assumptions? But those
That
are
the
based
Earth is
on
flat.
your assumptions of what's taking place. That's the problem.
So what do you think is happening? Or did I lose signal? You guys there?
Break up.
Sorry, did I miss you guys? Did I lose signal there?
Yeah, I think you're okay. I can hear you.
Okay.
Yeah, we can hear you now.
I mean, I get. Sorry about that. I get the distrust of like authorities and people in positions of authority, but this is something that you can look and check for yourself. You can get a ham radio. You can rent a ham radio or go to a
Yeah, that
astronomical
doesn't take place.
observatory or make a ham radio yourself.
So
Sorry, what's that?
you're conflating two different things. You're conflating a laser bounce with a some sort of radio bounce with a ham radio off of the moon. That's not taking place. The alleged claims of ham radio going the distance that it does is it's bouncing off the ionosphere. Those waves do not penetrate the ionosphere, which means they will not go past it and bounce off the moon. And then you have this alleged claim of the laser, which is a completely different radio like spectrum, right? It's a much more condensed wave that's taking place. So you're conflating the two of those. So maybe you need to figure out what your actual claims are first, instead of conflating two completely different things. And also don't make make assumptions that nobody ever brought up, like distrust for authority is what's led us to believe X, Y, and Z, because that might not be the case. So instead of just making broad assumptions, conflating different things, and not having the ability to see outside of what your preconceived ideas or assumptions are of what X, Y, and Z is, maybe ask more questions.
Yeah. So what's your explanation for it? I'm sorry if you've already answered and I just didn't understand.
Let's say you freaking you say, oh, that's your distrust. That's what got you guys not believing whatever. Like, no, it's like, I mean, that might be some people's. That might add to it after you freaking like watch the moon landing and then realize how freaking silly it is, and then watch some freaking ISS nonsense where they're all swinging around on wires. I mean, and then you laugh your ass off and you go, huh? Why would they fake all this bullshit? You know, probably because there's nobody up there floating around a tin can. And then you might go to, oh, these are the same people that you trusted to tell you some horseshit about this or that or 9/11 or it's all freaking connected. But I didn't start out with I distrust NASA. You know, I just started out with watching shit and laughing and realizing it's horseshit. So
Yeah, I'd just like to clarify something that Napalm said. EME communication is not off the ionosphere. Propagation delays are the same as laser ranging. So yeah, it's just ionosphere is just too close for that kind of delay.
Can you restate that?
The ionosphere is too close for the delays that you see in Earth, Moon, Earth radio communication. The delay that you see there is in alignment with what you see with laser ranging.
Yeah. I would agree with you on that. Maybe you should tell your Glober buddy that that's the case because he doesn't understand the difference between the two. He was conflating them.
Oh, you said that the EME is actually off the ionosphere. Oh, that's what I thought you said.
he said no, they
No,
bounce,
his claim
ham
was
radio waves off it.
yeah.
We were
His claim
saying
was
that
ham
they
radio.
don't bounce ham radio freaking signals off the moon to freaking tell its distance. That's what he was saying he did. Unless I'm
No, they do.
hearing
They
wrong.
do. It's one of the ham radio challenges is EME communication, where they bounce the signal off the moon somewhere on the other side of the Earth.
Bounce the signal off the moon. Okay, man. Yeah, whatever.
We got to find some way to hide the signal. It's gone for 2 seconds each way? So 4 seconds. Pretty hard to hide a signal for 4 seconds in the ionosphere, or even anywhere on the surface of the Earth. 4 seconds is many times around the Earth.
Refresh my memory on the globe. What's the Glober story about the new moon, where it goes for 3 days and then comes back? You know,
Doesn't go anywhere.
they still in the resurrects. Doesn't go anywhere. It just doesn't show itself.
Looking at the dark side of it. Only obscured by the sun. Laser ranging to it shows it's still there.
Kind of funny. Just kind of funny they named it, the new moon. If it's the old moon, if it's the same moon, I'll just go like, that's the same moon, not a new moon. Kind of